Alright class, quick demo for you. This is a lab you would have done, fourth quarter, but we're going to look at periodic trends, or that's kind of what we're looking at today anyways. So here's a quick lab on reactivity of metals. Alright, so I've got a glass of water here, and I'm going to put some water in 3 of these wells. Alright, and there's just a big well plate. So it has 24 little wells. That's why it's called a well plate. So this is red litmus paper, and you may have messed with it in biology or something like that. But if I stick it in a liquid and it stays red, that liquid is either neutral, alright, or it is acidic. Alright, if I stick it in and it turns blue, it means that liquid is basic. Okay, so I've got several metals here: aluminum, magnesium, and calcium. And we're simply going to stick a piece of metal in each well, and this is simply aluminum foil. So I'm going to stick it in the well, and got a piece of magnesium. And if you look at it, magnesium and aluminum are on the same period. They're on the 3rd row of the periodic table. So we're going to look at a row trend, and then magnesium and calcium are both in the 2nd group. So we're going to look at a group trend as well. I'm just going to have this guy sink, and nothing is really happening with those two. Alright, so calcium. These are just kind of little rocks of calcium. So about the same size as our magnesium and our zinc. And that's pretty much what it looks like. Just a little rock. So I'm going to stick it in the water. And hopefully we'll see something happening with one of these things. Yeah, so if you were to hear it, you could hear like bubbling and hissing. I don't see if we can lift it up here at all. That 3rd well. Yeah. Get some nice calcium bubbles. And again, folks, that is just water. Yeah, there's a nice thing. Like, see the bubbles forming right there. So with that, I'm going to stick this piece of litmus back in where we put the aluminum. And it's remaining pink. And I'm going to stick this one in where we put the magnesium, and it is remaining pink. And I'll stick this one in the calcium. Let's break that bubble up. And it turned blue. So it looks like as we go down a group, elements might become more reactive. Also, if you put your hand next to this, we see it gives off heat. And I'm going to stop the video right now, set up another one where instead of using water, we're going to use hydrochloric acid and do the same thing, and use a temperature probe to see what happens to the temperature of each of these things as we put them in hydrochloric acid. Alright, so part 2 of the lab. Just kind of mentioned to you, we're going to do hydrochloric acid in 3 wells. Otherwise, we're going to keep everything else the same. And hopefully I've got enough. Good enough. Alright, what we're going to say. So, same thing. We've got a lab quest. I'll kind of just get the original, or the initial temperature. Let's scoop this up a little bit. The hydrochloric acid. I don't know what it's saying. It's like 18.9. Alright. So this one we're going to do separately. We can't throw them all in because I've only got one temperature probe. But Put a piece of aluminum in there. All right. And 19 degrees. So not much is happening. All right. So throw a piece of magnesium in there. It'd be nice if these were all the same mass, but they're not going to be the same mass. Because obviously something that takes up more mass is going to cause a bigger reaction. But there we go. That's a good one. Drop that in there. Put the temperature probe in here. And from where I'm sitting, I can hear it bubbling already. So our magnesium is reacting with our hydrochloric acid. If you remember back to probably September, you had that challenge where you had to figure out how much gas you could produce. This is how we produced it. We used magnesium and hydrochloric acid back in the gas laws unit. We were looking at pivnert. So this is already up to 20.5. And I'll keep on stirring. $21.5, 22. So I'll kind of jump out of this one. Probably if we left it here, it might get up to 25, I would guess. All right, 24, 25. All right, and last we'll put a piece of calcium in there. And this one should obviously be more, but the main reason we did this one was just so you could see a difference between our row. Again, aluminum, magnesium on the same row. There was no difference here, but now we see that aluminum is reacting less than the magnesium, all right? And we already know from up here that if we're looking down a column, the further down we go, it seems to be more reactive. So once again, stick the temperature probe in. Looks like we're starting about 19.2. And I can hear some bubbling. Some more vigorous bubbling. And we're already past 32 degrees. Up to 50. All right, passing 60, so on and so forth. So, periodic trends, we learned about size trend, all right? Here's kind of reactivity of metals. So the further down you go, more reactive. The further to the left you go, more reactive. And what's weird is non-metals are exactly the opposite. So if we look at non-metals, the further up you go, the more reactive, and the further to the right you go, the more reactive. And I find that the noble gases aren't reactive at all, and thus the term noble. So anyways, quick demo would have been allowed for you guys. I hope you enjoyed that, and I need to figure out what to do with this at my house. Bye.